Hey everyone, Nitesh this side. Hope you are doing good. So let's start with the question. So the question is longest valid parenthesis. Okay, so what is given to us? We have given a string containing just the character opening and closing bracket. What we have to do? We have to find the length of the longest valid well-formed parenthesis substring. Okay, so this question is pretty similar to the there is a valid parenthesis question in which we just have to return whether the given string is valid or not, and on that we use a stack. Okay, so this question is pretty similar to that only, so let's understand with an example. Okay, so we have given this string, so you can see we have this then this. Okay, so if you can see, this is only the valid substring, and if I give the indexes 0 1 2, so we have getting the length of 2, which is a valid parenthesis. So we just need to return the length of the longest valid parenthesis. Similarly, if you can see for this, so we have this closing, then we have opening, then closing, then opening, then closing, and then we have closing. So if I give the indexing 0 1 2 3 4 5, so this is the balance valid parenthesis because these both are closing, so there is no opening bracket for this. So if we calculate the length for this, it is 4 minus 0, and that is 4. Okay, and this, if the length is empty, you just have to return 0. Okay, so I was saying this question is similar to valid parenthesis. Okay, so what we use for that question, we use a stack. Okay, and it returns whether the given string is true or false. So we use the same technique. So what we will do, we will start from I. So we'll start from 0 to n, and we will start inside this. We will start from I plus 2 to n. Okay, why I take I plus 2? Because we need to compare at the time. Like if we just pass only one character, j is I plus 1 and 0, so that's it is only one character. That's why I use I plus 2. So we'll pass two character at a time, and like 2 after 2 it will be increasing, and we check if is valid. Okay, so we'll call this function, and we'll pass this substring of I j, and we'll pass this string. If it is true, we'll calculate the maximum length. Okay, so by this we can solve this question. And if we see the time complexity for this, so this is also order of n, then similarly this is also order of n, and inside this we are calling a valid function, and that is also an order of n. Okay, so the time complexity for this is order of n cube, and for the space we will use a stack, so that's order of n. Okay, so if you do this question, it will not be submitted, so we need to see how we can optimize it. Okay, so we will use the same technique that we use for our previous approach, that we use a stack. Okay, so what we will do, like in stack, if you know the valid parenthesis, what we do for that, whenever we have opening bracket, we push it into the stack, and whenever we have closing bracket, we pop this. So we go with the same principle. So let me just give the indexing, and 0 1 2 3 4 5. So in the valid parenthesis we push this bracket. Okay, but in this case we will not push the bracket, we will push the indexing, because we want the length of the string. We don't need whether it is a valid or not, so we need a longest valid parenthesis which is balance. So let me just take a stack. So this is our stack, and initially I will start from -1. Okay, like already stack will have -1. I will tell you the reason why I have take this -1. So whenever we have closing bracket, we will pop it. Okay, so we will pop this. So let me just write the pseudo code. If character is opening bracket, then we'll do something, else we do something. Okay, so let me just write the else first. So if it is closing bracket, you need to pop this first. So you will just do stack dot pop, and after this you need to check if your stack is empty, Okay, if it is empty, then push this current index. So push current index, otherwise calculate the maximum length. So we'll calculate the length equal to max of length comma I minus stack dot peak. Okay, and if character is opening, we just push it to the stack. So stack dot push this current index. Okay, so what we will do, we will start from here. We can see this is a opening closing bracket, so we will first pop this. So we have popped this, and now we can see like our stack is empty, so we need to push this index. And you also got to know, like, we don't need to calculate the length because right now there is no valid string till here. So we'll move further. We'll come at here. We have an opening bracket and we'll push it. So we'll push the index. So we'll push 1. Now we'll move further. We have again a closing bracket. So we will pop this. So we have popped this. And now we can see our stack is not empty. We have a single element here. So we'll calculate the length. So we can see length is currently 0. And after this, we do I minus stack dot peak. So our currently top element is this and our current index is this. So we just do 2 minus 0, which is 2. So we'll update our length by 2. Again, we'll move further. We have an again a opening bracket. We push it. So we push the index. Now we again have an index. We have a close bracket. Okay. So this close bracket again, if you can see. So before this, you have to pop this. So you will pop this. Now you will again check whether your stack is empty. So stack is not empty. So you will do 4 minus 0, which is bigger than 2. So you will update by 4 and you will move further. Now again, you again see an closing bracket. So we will pop this. And if stack is empty, you will insert the new index. So you will insert. Okay, so you got to know like why we every time whenever our stack empty, that means after this there is no balance string. Okay, so we have calculated the maximum till here. Now if there is any string like this is only the valid answer till now. Okay, but if you can see this, after this is also valid, but its length is only 2. So we need a end pointer from where we can, like if I have to do 7 minus 5, I need that 5 index, because if it is not there, how can I subtract my previous pointer? And what's the use case of storing -1 is, let's say this is your string. Okay, so let me just take a stack. So 0 1 2 3 4 5. This is the opening bracket. Firstly it's -1, and this is the opening bracket. I will just push it, so I will push 0. Now again this is an opening bracket. I will push it 1. Now this is a closing bracket, so I will pop this, and my stack is also not empty, so I will update my length. So length will become 2 till here, because it is just giving me this only. Okay, after this I again see this is a opening bracket. I will push it, and again it's a closing bracket, so I will pop this, and again my stack is not empty, so I will update length. So length will become 4. Okay, now after this I come here, and okay, so I will come at here. Now I will do stack dot pop. So after stack dot pop, this element is removed and there is only a single element present here. So I will do 5 minus -1. So this will give me 6. So you got to know why we use the -1 and why I don't use a 0 or any other variable, because after, like, if my whole string is balanced, I need, like, indexing are from 0. So I need to do +1. So that's why I use up -1 here. Okay. And -1 is also useful when there is no, like, when the basically balancing is in between. Okay, so there is also one more string like this, and you need to check for this also, so then also it's necessary. So I think we can write the code for this. So what we just need a stack, integer new stack. Okay, we just initialize with stack with -1, and let me just take the loop over the string. Okay, and char c equal to s dot char at I. So if character is opening bracket, we'll do something, else we do something. Okay, if it is opening bracket, then just push it to the stack, and if it is opening bracket, pop the stack, and if your stack become empty, stack is empty, just push the current index. So stack dot push I, else you need to calculate the length. So let me just take a length variable equal to 0. Okay, len equal to math dot max len I minus stack dot pick. Finally, we just return the length. Okay, so let's run it. Okay, I don't know why it is sign out. Okay, let's run it. So this is accepted. Let's submit it. So our code is submitted. The time complexity for this is, yeah, you just using a loop over a string, so that's a order of n, and you are using an extra space, so that is also an order of n. And there is one more technique that you can use is, let me just explain you also. So 1 second, you are given this string. Okay, this is a string. Okay, and we know, like, we need to get the longest valid parenthesis. Okay, so that means it's number of opening bracket plus number of closing bracket, they need to be same. Okay, and their sum is equal to our longest valid parenthesis. It needs to be necessary. So what you can do is, you will can, like, this is a string, so you can go from here, and every time you can calculate your left and right. Okay, and wherever your left or right is equal, that means there you can calculate your longest valid parenthesis. So let me just give you the example. So we are here, and we can start from here. So let me just take two variable, open and close. So we will start from here. Okay, so we will start from here, and we can see our close is there, so we'll increment our close. Okay, and every time we need to increase open and close, and we need to check whether open equal to close, so we'll calculate the length. And whenever your close become greater than open, you just need to do every time update. So you can see your close is greater than open, so you will make it 0 again, and this is also 0. So now we'll move further. We come at here, we again increase, so this will become 1. Now we'll move here, we again increase, so this will become 1. Now you can see they both are equal, so you will calculate your length. So length will always be double of open or close either, because, or you can do open plus close. So open plus close, so you will do every time, and you take max of length. So whatever there, so you will do length is start from 0, so open plus 0 is 2, so 2 will take 2. Now we'll move further. Again we see an opening bracket, we'll increment it. Again we see a closing bracket, we increment it, and they both are equal, so again we have either 2 or we have 2 plus 2, so we'll take 4. Now we'll move further. Now our close is greater, so whenever your close become greater, you just need to make close equal to 0 and open equal to 0, because after this there will be no, before this, because we need to get the substring, not the subsequence, so this will not count after if there is any valid substring. Okay, so you need to go from this direction also, and you need to go from this direction also. So for that, if we calculate the time complexity, that is only order of 2, and you can say, or n plus n, it's order of n only. But we have removed the stack, so that for the space it's order of 1. So yeah, you can try this with your own. It's just a loop over a string. So yeah, hope you like it. Thank you for watching, and do join the Telegram if you're in doubt any concern. Thank you.